In this example, you can see that we're doing multiple operations at once. First, we have addition, and then we have subtraction. So we go about it in the same way. The first thing that we want to try to do is factor in the denominator wherever we can. So this is not factorable. We can factor this as the difference of squares, and then the third denominator is not factorable. So I'm going to go ahead and factor out that second denominator. Alright, so that becomes x plus 1 and x minus 1. And the third denominator is not factorable. So again, we want to find the LCD. We want to take a look. We have an x minus 1. Now the most number of times that we see an x minus 1 in a denominator is once. So we want to have one of those. Next, we already have this x minus 1. We have an x plus 1. The most number of times we see an x plus 1 in any of the denominators is once. So we need one of those. And there are no other factors that need to be represented. So let's go ahead and start making all of our denominators match. What we're going to do in the first denominator, since we already have the x minus 1 part, we need to multiply an x plus 1. Now remember that whatever you do to the denominator, you must also do to the numerator. The second denominator already matches. It may not be in the same order, but we know that multiplication is commutative, so that doesn't matter. So nothing needs to be done to the second fraction. The third fraction has an x plus 1, but it needs an x minus 1. So let's also multiply an x minus 1 in the numerator. Alright, so let's go ahead and start simplifying. We can distribute. Just be careful with one thing. We do not want to cancel these out. If we cancel these out, we're back at square one where we have denominators that don't match. Alright, so make sure you do not cancel them out. So we're going to end up with 7x plus 7. And you know what? I'm going to put all of this over that denominator right away. Alright, so I'm ready to combine my numerators because my denominators are all common now. So I distributed here. I have a plus 10x. Alright, now this is similar to the previous example that we just did. I'm going to distribute this, so I get a 5x minus 5, but I also have to distribute this negative into that simplified expression. So I'm actually going to have a negative 5x and a positive 5. Alright, so let's go ahead and combine our like terms. The denominator still is the same. So I can combine all of my x's. So we have 7 plus 10 is 17, minus 5, we have 12x. 7 plus 5 is 12. And thinking ahead, I can see that if I factor the numerator, I'm actually going to be left with a factor, a term that is actually going to cancel out. You always want to check that in the numerator. You kind of want to plan ahead, because if you can factor something out that will eventually cancel out, that's when you want to factor. If not, it's not necessary to factor, but you don't know until you actually factor it. So I pulled out a GCF of 12, and now these two terms cancel. My final answer is 12 over x minus 1.